cozy yet? Can you hold up? Don't need no coffee yet. Got no makeup.
Good day and welcome back to my channel. It's been a long time that I was not able to create a video because we are so busy with our modules. Okay, now this time I'm going to discuss about factoring perfect square trinomial. Okay, before we are going to factor out perfect square trinomial, it has have a review on this a plus b quantity square. This is called square of binomial. It's called square of binomial. Binomial, you have two terms. This is the first term and this is the second term. Square. Now, square of binomial can be expressed into a trinomial. How? Just square the first term. Our first term here is a. So if we are going to square a, we have a squared. Then twice the product of the first term and the second term. Twice the product of the first term and the second term. Our first term is a and our second term is positive b. So a times b, that is plus ab twice. So again, square the first term. Our first term here is a, so we have a squared. And then the second term will be the product, or the second term will be the twice the product of the first term and the second term. Twice the product of first term and the second term is a times b. And then for the third term, square the second term. Our second term here is positive b. So if we are going to square positive b, we have b, positive b squared. This is now called trinomial. We say trinomial, we have three terms. First term, second term, third term. Trinomial. And this trinomial is called perfect square trinomial. So this is called a perfect square trinomial. So we can say that square of a binomial can be expressed or equal to a perfect square trinomial. And that is the process. Okay? If we have a minus b quantity squared, this is a square of, again, a binomial. This is the same thing with this, square of binomial. But we have, the difference is the operation in between. Now, as I said, the process are the same. We can express this one into a perfect square trinomial. Just square the first term, we have a squared. And then twice the product of the first term and the second term. Twice the product. The product of this is a times negative b is negative ab. So we have negative ab. And then square the second term. The second term here is negative b. So if you square negative b, it becomes positive b squared plus b squared. Okay? So that's the process. So a square of a binomial will become a perfect square trinomial. Okay? So that's it. Example. We have number 1, x plus 2 quantity squared. If we are going to make this one into a perfect square trinomial, this will be square of the first term. Our first term here is x, so we have x squared. And then, since plus, the operation here is plus, so we can write here plus. Then twice the product of the first term and the second term. the first term is x and the second term is 2. So if we are to multiply 2 times x, that is 2x. Okay? Do not forget 2 because it is twice the product of the first term and the second term. That is 2x. Again, twice. Meaning to say, 2 is constant here. 2 is constant. And then, the number that you are going to write here is the product of the first term and the second term. Now, the product of the first term and the second term is 2x. So, we have here 2x. And then, it's always plus here. It's always plus. It's always plus. Now, the third term is square of the second term. Our second term is 2. So, we are 2 squared. Let us simplify. We have x squared. Multiply these terms. That is equal to 4x. Because 2 times 2 is 4. Then copy x. Plus 2 squared is 4. Now, this is now the perfect square trinomial of this square of binomial. Another one. If we have x minus 3 quantity squared. Okay. We are going to make this one into a perfect square trinomial. So the process is the same. Just square the first term. We have here x squared. Since our operation is minus, so we have here minus. And then twice the product of the 2. The product of the 2 is 3x. The product of x and 3. Okay? And then square the second term. The second term here is negative 3 squared. That is our second term. And then simplify. X squared. Multiply these two numbers here. You have negative 6x. And then square negative 3. That is positive 9. This is now called the perfect square trinomial of the square of binomial. Another example, we have here number 3. We have 2x plus 5 quantity squared. Square of binomial. So this is the square of binomial. So we can now, again, we can express square of binomial into perfect square trinomial. Same process. Square the first term. So the first process is square the first term. Okay? The second one is twice, at the second term, twice the product of the first and second term. And the third one, square the second term. Okay, so let us follow these steps. First one is square the first term. Okay, so the first term is 2x. So we have 2x quantity squared. 2x is our first term. And then twice. Again, do not forget to determine the operation here. The operation is plus, so we have here plus. Then twice, copy 2. Product of the first and the second term. Our first is 2x. Product of 2x. And the second term, 5. That is our second term. That's our second term. For the third term, square the second term. Our second term is positive 5. So 5 squared. Then let us simplify. 2x quantity squared is 4x squared. Okay? 2 times 2 is 4, then x squared. Then multiply these three terms. 2 times 2x, that is 4x, times 5, that is 20x. Plus, square of 5 is 25. Okay. So, that is the process in expressing a square of a binomial into a perfect square trinomial. The first step is square of the first term. The second term is twice the product of the first and the second term. And the third term is square of the second term. Okay, do not forget that is the process. Okay. in dealing with perfect square trinomial, do not forget numbers that are perfect square numbers. What are perfect square numbers? So if a number is squared, the result is a perfect square number. For example, if we have 1 squared, the result is 1. So 1 is a perfect square number. If we have 2 squared, the result is 4. So 4 is a perfect square number. If we have 3 squared, the result is 9. And so 9 is a perfect square number. If we have 4 squared, the result is 16. So 16 is also a perfect square number. 5 squared, the result is 25. That's 5 times 5. If we have 6 squared, the result is 36. If we have 7 squared, the result is 49. So if you continue the process, the result is called a perfect square number. Okay. Now, how to determine a trinomial, a perfect square trinomial? Example. Is this a perfect square trinomial? Yes or no? Now, how we are going to determine? Okay. Let us go back with our example earlier. Square of binomial. Again, square of binomial can be expressed as a perfect square trinomial. So, what is the step again? The first one is square the first term. So we have x squared. Then the sign here is positive, so we have positive. Twice the product of the first and the second is 2x plus square the second term. The result here is x squared plus 4x plus 4. Now, this is called a perfect square trinomial. Now, if you observe in this trinomial, the first and the last term, or the first and the third term, is a perfect square number. Right? As I said earlier, if a number is squared, the result is a perfect square number. So therefore, x squared is a perfect square number. 4 is a perfect square number. The first term and the third term are perfect square numbers. These are perfect square. Okay? Now, take a look on the second term. The second term here is 4x, or the coefficient is 4. Now, what is the relationship between the first term and the third term? There is a relationship with this. Now, 4x could be expressed as twice the product of the square root of the first term and the square root of the last term. Let us put x here. X is the variable. Now, what I am trying to figure out is how we are going to determine a perfect square trinomial. So, first thing is, take a look if the first and the third term is a perfect square number. Okay, that's the first condition. Perfect square numbers ang first at ang third. Now, the second condition, okay, the coefficient, let's forget x. Let us forget x. Okay. Let us now focus on the coefficient of x. That is 4. Now, 4 could be expressed as 2 times the square root of 1 times the square root of 4. Where is 1 coming from? 1 is the coefficient of our first term. Coefficient of x squared is 1. Where is 4? That is our third term. So if you simplify, what is the square root of 1? The square root of 1 is 1. Square root of 4, that's 2. If you multiply these three numbers, the result is 4. Okay, let us conclude. We can determine a perfect square trinomial if the first term first and third term, or last term, are perfect square number. Perfect square numbers. Okay? The second is coefficient. The coefficient of the second term is twice the product of the square root of the coefficient of the first and third term. Okay. The coefficient of the second term is twice the product of the square root of the coefficient of the first term and the coefficient of the third term. Or, yes, the third term. Here, the first term and the first term and the third term are perfect square numbers. Check. How about the second condition? The coefficient is 10. 10. Now, is 10 equal to twice the product of the square root of the coefficient of the first term? Coefficient is 1. Okay, here, times the square root of the coefficient of the third term, or the third term is 25. And the square root of the third term. And the square root of third. Okay. Now, 2, what is square root of 1? 1. Square root of 25, that's 5. Multiply these three numbers, the result is 10. So correct. Therefore, this trinomial is a perfect square trinomial. Again, in order to determine that a trinomial is a perfect square trinomial, let us consider these conditions. The first condition is first and third term are perfect square numbers. Then, second condition, the coefficient of the second term is twice the product of the square root of the coefficient of the first term and the square root of the third term. Another example. Example number 2. We have here x squared plus 16x plus 64. Okay. Is this a perfect square trinomial? Let us check. First and the third are perfect square numbers. Is x squared a perfect square number? Yes. Is 64 a perfect square number? Yes. 64 is 8 squared, or 8 times 8. That is 64. So therefore, 64 is a perfect square number. Now, the second condition, the coefficient of the second term. The second term is 16x. The coefficient is 16. Is twice the square root of the coefficient of the first term is 1 times the square root of the third term. Okay? 2. Square root of 1 is 1. Square root of 64 is 8. Multiply these three numbers, the result is 16. So these numbers are equal. Therefore, this trinomial is a perfect square trinomial. Okay, another example. We have, let's say, 4x squared plus 4x plus 1. Okay. Is this a perfect square trinomial? Let us consider our conditions. First and the third term are perfect square numbers. Is 4x squared a perfect square number? Yes, because 4 is a perfect square number. Is 1 a perfect square number? Yes. So check. The second condition, the coefficient of the second term is twice. So the coefficient of our second term here is 4. So 4 is twice the square root of the coefficient of the first term, that is 4, times the square root of the third term, that is 1. Okay? So we have 2. What is square root of 4? That is 2. Square root of 1, that is equal to 1. Multiply these three numbers, the result is 4. Since they are equal, therefore this is number 3. Therefore this trinomial is called a perfect square trinomial. Okay? So that's the conditions. That is the process or the condition in determining a perfect square trinomial. Okay? Let us now continue factoring perfect square trinomial. Example. Now, factoring perfect square trinomial is very easy. The first that we should do is to determine that a trinomial is a perfect square trinomial. So like for example here, x squared plus 10x plus 25. This is a perfect square trinomial based on our previous discussion on determining a perfect square trinomial. Okay. So if this is a perfect square trinomial, it is very easy to factor. Just create a here. In our previous discussion, we express square of binomial into perfect square trinomial. Now, if this is a perfect square trinomial, we can express it also as square of binomial. So that's vice versa. Now how? Just get the square root of the first term. Square root of the first term. So the process is get the square root. Get the square root of the first term. So the square root of x squared is x. Then the second condition or second process is get the square root of the third term. Get the square root of the third term. Get the square root of the third term. The third term is 25. Square root of 25 is positive 5. Square of binomial. Now, a square of binomial could be expressed into, rewrite into x plus 5. X plus 5. Because here, exponent determines how many times it appears the base. For example, x squared. X squared is x times x. If you have 2 squared, that's 2 times 2. If you have 3 squared, that is 3 times 3. Now, this is now the factors of our trinomial. Another example. Here, number 2. 4x squared plus 4x plus 1. Okay, we know already this one, that this is, okay, this is a perfect square trinomial, yeah, yes. So, as I said, it is very easy to factor out perfect square trinomial. Okay. Just follow the process. We have create a square of binomial here. Get the square root of the first term. Square root of 4x squared. Square root of 4x squared. Square root of 4 is 2. Square root of x squared is x. Then plus, because the operation is plus, is square root of 1. 1. So therefore, we have here 2x plus 1 times 2x plus 1. These are now the factors of 4x squared plus 4x plus 1. Another example. number 3. We have here number 3. We have here a squared plus, let's say, 14a plus 49. Okay? Is this a perfect square trinomial? Yes or no? Okay, let us check. Perfect square trinomial. Is a squared a perfect square trinomial? Yes. Is 49? No. Is a squared a perfect square? Yes. Is 49 a perfect square? Yes. First condition is checked. How about the coefficient of the second term? 14. Okay. 14 twice the square root or the product of the square root of the coefficient of the first term times the square root of the third term. 2. Square root of 1 is 1. Square root of 49 is 7. Multiply, the result is 14. So therefore, the second condition is checked, the first condition is checked. Therefore, this trinomial is a perfect square trinomial. And if this is a perfect square trinomial, it is very easy to factor out. Just create a square of binomial here. Get the square root of the first term. A squared is, square root of a squared is a. The operation is plus. Okay. And then square root of 49. Get the square root of the third term. Square root of 49 is 7. And we can rewrite this one as a plus 7 times a plus 7. So, the factors of this one is a plus 7 times a plus 7. Another example. We have here b squared minus, let's say, 4b plus 4. Okay. Is this a perfect square trinomial? Okay, is this a perfect square trinomial? Let us check. Is b squared a perfect square number? Yes. Is 4 a perfect square number? Yes. Let us check for the second coefficient of the second condition. Coefficient is 4. So it's twice the square root times the square root of 1 times the square root of 4. So you have 2. Square root of 1 is 1. Square root of 4 is 2. Multiply, the result is 4. So this is a perfect square trinomial. So create square root of b squared. Let us apply it here. Square root of b squared is b. What is the operation here? Minus. Square root of 4, which is 2. Okay? So let us rewrite this one into two factors. So we have b minus 2 times b minus 2. So these are now the factors of b squared minus 4b plus 4. Okay. Is this a perfect square trinomial? And let us check. Is x squared a perfect square? Yes. Is 49y squared a perfect square? Yes. How about the coefficient of the second term? 14. So we have 14. It should be equal to twice the square root of the coefficient here is 1 times the square root of the third term, that is 49. Okay, 49. Now, 2, square root of 1 is 1. How about square root of 49? That is 7. Multiply. 2 times 1 times 7, that is equal to 14. So, equal. Therefore, this is a perfect square trinomial. Okay. Now, we can factor out this one by creating a square of a binomial. Get the square root of x squared, that is x. Copy plus square root of 49 y squared. Is the 7y. Okay. The third term is 49y squared. So square root of 49 is 7. The square root of y squared is y. Now let us create this one into factors. X plus 7y times x plus 7y. Okay, another example, number 6. 3x squared minus 18xy plus 27y squared. Now, is this a perfect square trinomial? Let us check. Is 3x squared is a perfect square? No. Is 27y squared a perfect square? No. So, the first condition is not satisfied. So this is not a perfect square trinomial. But we can factor out the greatest common factor with these three terms. What is the greatest common factor of these three terms? So we have 3. Yes, 3. Factor out 3. What will be the result if you factor out 3? 3 divided is 1, so it becomes x squared. Negative 18 divided 3, that's negative 6xy. 27 divided 3, that is 9y squared. Okay, we factored out 3, which is the GCF of these three terms. Now, is this a perfect square trinomial? Let us check. Is x squared a perfect square? Yes. Is 9 squared a perfect square? Yes. How about the coefficient of the middle term? That's 6. Is equal to twice the square root of twice times the product of the coefficient of the first term times the square root of the third term. That's 9. 2 square root of 1 is 1. Square root of 9 is 3. Multiply 2 times 1 times 3 is equal to 6. Therefore, this trinomial is a perfect square trinomial. So we can factor out this. So we have 3 times square root of x squared, that is x. What is the sign here? Minus. Square root of 9, 3. Square root of y squared, that's y. Okay. So we can factor out this one. We have 3x minus 3y. Or we can rewrite this one in a factored form, x minus 3y. So therefore, the factors of this trinomial is this one. 3 times x minus 3y times x minus 3y. Okay? Example number 7. 75t squared plus 30t plus 3. Is this a perfect square trinomial? Let us check. Is 75t squared a perfect square? No, because 75 is not a perfect square number. So therefore, this is not a perfect square trinomial. But we can have a common factor, which is GCF of these three terms. That is, again, 3. Okay? 75 divided 3, that's 25. T squared. 30 divided 3 is 10. 3 divided 3 is 1. Let us check if this is a perfect square trinomial. Is 25t squared a perfect square number? Yes. Is 1 a perfect square number? Yes. Let us check the coefficient. 10 is equal to twice times the product of the square root of the first term, or the coefficient of the first term, times the square root of the third term, 1. 2. Square root of 25 is 5. Square root of 1 is 1. Multiply 2 times 5, that's 10 times 1 is 10. That's true. Correct. The first condition is correct. The second condition is correct. So this is a perfect square trinomial. So we can factor out this because this is a perfect square trinomial. So 3. So create a square binomial here. Square root of 25t squared is 5t plus the square root of 1, that is equal to 1. Then rewrite this one in a factored form. 3 times 5t plus 1 times 5t plus 1. So this is now the factors of this 75t squared plus 30t plus 3. Okay? Factoring not a perfect square trinomial. There are two forms of not a perfect square trinomial. The first, trinomial, standard form of a trinomial. It does have a standard form or form of a trinomial. We have ax squared plus bx plus c. Here, where a is equal to 1. Then another form, we have ax squared plus bx plus c, where a is not equal to 1. So these are the two forms. Let us now have here the first form, ax squared plus bx plus c. Example. Okay, x squared plus 3x plus 1. The octahedral trinomial that is not a perfect square trinomial and a is equal to 1. You are going to list all the factors of the third term. Our third term is 2. So that's going to list all the factors of 2. So we have 2 times 1. Okay? 2 times 1 is 2. We have also negative 2 times negative 1. So 2 times 1 is 2, negative 2 times negative 1 is 2. So these are the factors of 2. 2, 1, negative 2, and negative 1. Now, if we are going to get the sum of these two factors, we have 2 plus 1, the result is 3. Negative 2 plus negative 1, the result is negative 3. Now, what is the relationship? Why I get the sum? So here, the sum should be equal to the coefficient of the middle term. Now, with these two pairs of factors, 2 and 1 are correct. Because if we get the product of 2 and 1, the result is the third term. If we get the sum of these 2 and 1, the result is 3. So this is the sum, and this is now the product. The product, the sum. So this is now the factors. So if we're to factor out x squared plus 3x plus 2, just create two pairs of parentheses, then factored out x squared. The factors of x squared is x times x. Okay? Then select the factors of the third term, that the product is the third term and the sum is the coefficient of the middle term. So we have here 2 and 1. Positive 2, positive 1. Or it could be right here, also here we can say positive 1, positive 2. It's also correct. It's also here positive 2, positive 1. It doesn't matter. It doesn't matter. Now, how we are going to say that, or how are we going to convince that x plus 2 and x plus 1 are correct? Are the factors of x squared plus 3x plus 2. Now, if you remember the FOIL method, let us check that these factors is correct. So we are going to try to use FOIL method, x plus 2 times x plus 1 by using FOIL method. How we are going to use FOIL method? Just multiply the how we are going to use the FOIL method? Multiply the first term and the first term of the two binomials. So f, first term times the first term, that's equal to x squared. That is our first term, f. And then o, because we are using FOIL method, o, outer term. So we have here the outer term. It's o, x times 1. That is plus x. And then I, inner term. Here the inner term, here, 2 and x. 2 times x, positive 2x. And then L, the last term of the two binomials. The last term of x plus 2 is 2. The last term of x plus 1 is 1. So 2 times 1. That is our L. It's our I. Okay, F, x times x, first term. O, the outer, x and 1. And the inner, 2 times x. In the last term, 2 times 1. 2 times 1 is positive 2. Then after using the FOIL method, you are going to add like terms. Here the like terms are x and 2x. So just copy x squared. Add these two numbers here. X plus 2x is positive 3x plus 2. So we, after using the FOIL method, just add the like terms, and then are they the same? X squared plus 3x plus 2, correct. So therefore, the factors of x squared plus 3x plus 2 are x plus 2 and x plus 1. Another example. X squared minus x minus 12. List the factors of the third term. That's negative 12. So negative 12 could be negative 12 times 1. Then also say 12 times negative 1. That's negative 12. We have also Negative 6 times 2, that's negative 12. We have also 6 times negative 2, that's also negative 12. We have 4 times negative 3, that's negative 12. We have negative 4 times 3, that's negative 12. What else? No more. Now, get the sum of these factors. You have negative 12 plus 1. The result is negative 11. You have 12 plus negative 1. The result is 11. You have negative 6 plus 2. The result is negative 4. You have 6 plus negative 2. The result is 4. 4 plus negative 3 is equal to 1. Negative 4 plus 3, that's equal to negative 1. It's equal to negative 1. Now, we factored out negative 12. Now, among these factors, where is the factors that the sum is equal to the coefficient of the middle term? Our coefficient of the middle term is negative 1. So, where is that factor? The result is negative 1. Here, negative 4 and positive 3. So, this is on the factors. So, you can have now the factors of x squared minus x minus 12 is equal to just create two parentheses here, two parentheses. Then factor out the first term, that is x times x. Then write the factors that are correct. So that's negative 4, positive 3. Do not forget the sign. If 4 is negative, so use negative 4. You can also write the negative 4 here, and here is the positive 3. It doesn't matter, as long as the sign doesn't interchange. Okay? Again, the product of negative 4 and 3 is the third term. And the sum of this negative 4 and 3 should be the coefficient of the middle term. That is a is equal to 1. Another example. X squared minus 2x minus 24. Because list all the factors of the third term. It's negative 24. Could be also negative 24 or negative 24 is equal to negative 24 times 1. It's correct. It's also equal to 24 times 1. 24 times negative 1. We can also have 12 times negative 2. That's negative 24. We can also have negative 12 times 2. We can also have 8 times negative 3. You can also have negative 8 times 3. Also 6 times negative 4. And negative 6 times 4. What else? No more. So if you are confused with our design, do not forget that positive times positive, the result is positive. Positive times negative, the result is negative. Negative times positive, the result is negative. Negative times negative, the result is positive. Multiplication of signs. So, that's it. Then get the sum of these factors. Negative 24 plus 1, the result is negative 23. 24 plus negative 1, the result is 23. 12 plus negative 2, the result is 10. Negative 12 plus 2, the result is negative 10. 8 plus negative 3, the result is 5. Negative 8 plus 3, the result is negative 5. 6 plus negative 4, the result is 2. Negative 6 plus 4, the result is negative 2. Okay. If you are confused with this sum of or addition of integers, if the two integers having different signs, we are going to subtract. Then copy the sign of the bigger number. So here, subtract because the sign of 24 is negative and the sign of 1 is positive. So 24 minus 1 is 23. And what is the sign of our bigger number? Negative. So our answer is negative. The same. Here, unlike signs, we're going to subtract. 24 minus 1 is 23. The sign of the bigger number is positive. The result is positive. 12 and negative 2, they are having different signs. So we're going to subtract. 12 minus 2, that's 10. And the sign of our bigger number is positive, so the result is positive. Here again, unlike signs, so you're going to subtract. 12 minus 2 is 10. But the sign of our bigger number here is negative, so our answer is negative 10. Here, 8 plus negative 3, so we are in the subtract because the sign because they have different signs. 8 minus 3, that's 5. The sign of the bigger number is positive, so the result is positive 5. Here, negative 8 plus 3, the numbers having different signs, subtract. 8 minus 3 is 5, and the sign of the bigger number is negative, so negative is our answer, and so on. Okay, now based on these factors, what factors having the sum of negative 2? Because our coefficient of the second term is negative 2. So negative 6 and 4. So that is our factors. Now, so therefore, the factors of, on the right here, the factors of x squared minus 2x minus 24 are create a two binomial. Here, two pairs of parentheses. We have here x times x. Then we choose negative 6 and positive 4. Because that the factors are correct. Okay. So negative 6 and 4 is the correct factors. Let us check if these two factors are correct by using FOIL method. Let us check using FOIL method. By using FOIL method, we have x minus 6 times x plus 4 by using FOIL method. Okay. F. First term times the first term. X times x, x squared. O. Outer term. X times 4. That's O. That is positive 4x. Okay? Then I. The inner term. 6 times negative 6 times x is negative 6x. Then L, the last term. Negative 6 and 4. Negative 6 times 4 is negative 24. Okay. It's negative 24. Combine like terms. These two terms are like terms. So x squared, it's x squared. X times x is x squared. Copy x squared. Going to subtract because the two numbers having different signs. So 6 minus 4 is 2. And the sign of the bigger number is negative, so we have negative 2. Copy x, copy minus 24. Are they correct? Yes, correct. So therefore, x minus 6 and x plus 4 are factors of x squared minus 2x minus 24. That is if a is equal to 1. Now, how about if a is not equal to 1? Example, factoring not a perfect square trinomial where a is not equal to 1. 2x squared plus 3x plus 1. Third term is 1. So we are going to write here the factors of 1. We have 1 times 1 and also negative 1 times negative 1 because negative times negative is positive. So these are the two factors. Now, what we are going to do is we are going to use a trial and error method. Just factored out the first term. What is our first term? 2x squared. Just factored out 2x times x. Factors of 2x squared is 2x and x. Now, take a look on our example. We have two, when you say the operations are all additions, so we are pretty sure that this is plus and plus because all operations here are addition. That's the pattern, no? Plus, plus. Now, our main concern here is our second term of the binomial. We cannot apply the sum of these two factors because our a is not equal to 1. We can only get the sum of these factors if a is equal to 1. Now, how we are going to do? You use trial and error method. We are going to try 1 and 1. So try 1, 1. How do we know that these two factors are correct? If you use FOIL method, we can use FOIL method, but it makes us long. It makes us, yes, a long time. What we are going to do is to multiply the inner term. 1 times x, that is x. Then multiply the outer. that's 2x. After multiplying the inner and the outer, get the sum, 3x. Are they the same? Correct. They are the same. So if this sum here of the product of the inner and the outer is equal to the second term, therefore, these factors are correct. Okay, another example. That's correct. Man. So the factors of 2x squared plus 3x plus 1 are 2x plus 1 and x plus 1. Okay, another example. We have 2x squared plus, let's say, minus 5x plus 2. Same. So we are going to list the factors of 2. Factors of 2. We have 2 times 1, and we have negative 2 times negative 1. There are only 2 factors of 2. Okay. Create a 2 parentheses here. Then factor out the first term. We have 2x times x. Or we can make x times 2x. No, it doesn't matter. As long as the factors are correct. Okay. There are 2 factors. If, as you observe, minus plus, we are not pretty sure that plus, it's because here is not the same. So, not plus. Okay. What we are going to do is to try negative 2 and negative 1. It's actually negative 2, negative 1. We use this one. Let us check if these factors are correct. So, multiply the inner, that's negative 2x, and multiply the outer, that's negative 2x. Then after multiplying, that's going to add. Negative 2x plus negative 2x, the result is negative 4x. Right? Are they the same? No, they are not the same. So, this is not the factor. If it interchange the number here, we have here 1 and we have here 2. Let us check by using, again, multiplying the inner, that's negative x. Multiplying the outer, that's negative 4x. Add, that's negative 5x. Because we have here negative 1 plus negative 4 is negative 5. Copy x. Are they the same? Yes, they are the same. So therefore, the factors of 2x squared minus 5x plus 2 is equal to 2x minus 1 times x minus 2. Okay? Nakita ninyo ang diferensya? Nagbinisaya na ko kay kapoy na kong in-English. So, if you observe, if a is equal to 1, mo to siya ang process primero. If a is not equal to 1, mo na siya ang process. So, mo to siya mga estudyante, how we are going to factor out perfect square trinomial, and how we are going to determine that a trinomial is a perfect square trinomial. Then how we are going to factor out a trinomial that is not a perfect square trinomial, where a is equal to 1, or where a is not equal to 2. Where a is not equal to 1. Okay, thank you for listening. Thank you for watching. And if you are new with my channel, do not forget to subscribe. Click na niyo mong subscribe diha anya hasta ang notification bell para you will be updated for more videos that I'm going to upload in my channel, especially to our students today. Thank you and good day.